All right, you're welcome back once again. My name is Victor Digumore here, and in this class, we are going to be going into the understanding of polygons. The understanding of polygons. We are going to start from the scratch, and in doing that, we are going to see us take you through some theorems around triangle, because that's the basic. So we are going to start from there. If you were in the last class, you saw or you were following us, you realize that in the last class we were discussing or we are looking at a review of the last concluded WIC examination. Please, it is important you check out that class so that you see what we are doing, because any moment from now we are going to be doing a revision of that question. I mean, the question that is written for WIC examination for this year 2025. So we'll be solving all the questions that are contained in that question paper. So you check out in the last class so that you see what we have discussed there, some of the points that we raised that can help you to understand what you're supposed to know or what you're supposed to be doing. Okay, back to what we have today. If you have two lines of this nature, a line like this and another line like this, we normally say, or take for instance, if we say that this line is parallel to this line, okay, and we can also put up a transversal this way, okay. If something like that happens, then you can be making some observation. That observation is that you will realize that this angle here and this angle here, they are equal. Reason: if this is, let me call this A1 and call this A2, we say that A1 is equal to A2. We call them corresponding angles. That is to say that corresponding angles are equal. Now, I want to do something again. You see, this line, I drew it this way. But what about if this is these two parallel lines and I put up this transversal this way? Look at it. Okay? You also realize that something is going on here and here. So we call this angle and this angle alternate angles. We say they are what? Alternate. They are alternate. And alternate angles are equal. So let me do it here. Let me put up something like this. Okay. If I have it this way, right? So you realize that I have been able to achieve something again here and here. So if this is my B1, this will be B2 by me. And another thing we discovered is that B1 is equals to B2. Reason: they are called alternate angles, and alternate angles are also equal. Now we are heading somewhere. We are heading somewhere. Do you realize that if I bring down this diagram to exist in this way, to exist like this. Okay, so do you see that there is something here? Okay, so what you discover is that we have this to be b1 plus, is it b1? Okay, by my choice, this is a2. Okay, this is supposed to be b2 because I have b2 here. Okay, so let this be b2 plus a2. Okay, and let me now have inside here b1 and here a1. I'm sure it's looking good now. So you realize that if we have said that this and this are equal, and this and this are equal, obviously we are saying that from here that this angle a1 plus this angle b1, they are equal to the angle we have outside here, b2 plus a2. What have we been able to establish? We have been able to see that this is the theorem we are heading to derive, that external angle of a triangle is equal to the sum of two opposite interior angles. I believe that what we did here is so simple. Look at it again. Look at it again. This is corresponding to this, and by corresponding angles they are equal. This is alternate to this, by alternate angles they are equal. So if we have accepted that this and this are the same, and this and this are the same, it then means that this plus this will be the same thing as this plus this. That's a1 plus b1 will be equals to b2 plus a2. It then means we can conclude that external angle of a triangle, this is external to this triangle, external angle of this triangle, this is equal to the sum of two opposite interior angles. This is a very simple way to show this theorem, that external angle of a triangle is equal to the sum of two opposite interior angles. I'm sure that is very, very good. Now, we just want to make a little extension on this. And that little extension is that we are going to be showing from here now that the sum of angles in a triangle is equal to 180 degrees. Okay? So it's just a little extension we are going to put here. Now, if I come back here and put something here, if I put something here as C, okay? So do you realize that here I will be having C plus B2 plus A2 equals to 180 degrees. Why? We say that this is angle on a straight line. This is 180 degrees for sure. All right. Do you also realize that this C again plus, let me take B1 first. B1 plus A1 is equals to 180 degrees. Now, if you look carefully at this, that C is here and this is this, and C is here, and this 2 now is this 2. And if this C and these 2 angles make up 180 degrees, and C is here again, and the same thing repeated, then we can conclude that this which is 180 degrees is also this must be 180 degrees. I don't know if that is very clear to us. If this is this, then this is repeated here. And if we have logically seen that this is 180 degrees, then it means conclusively that this must be 180 degrees. This is a simple way to show that sum of angles in a triangle is 180 degrees. I just believe that this explanation is very simple and does make a lot of sense to us. So, what else? Please, with this little explanation and breakdown, we are going to bring or go into the understanding of polygons. We'll be solving problems around polygons, and it is important you follow us. When we talk about polygons, we are talking about shapes that have number of sides, like this. This is a triangle, and this triangle now, it has three sides. Three sides. So if this triangle that has three sides is we have three angles there. We uh, have n being 3, and some of the angles being 180 degrees. So you will realize that there is a general expression that we use in obtaining the sum of angles in a polygon. That expression is n minus 2 bracket 180 degrees. This n here is the number of sides, okay? Number of sides in that polygon. Of course, in a triangle, you have three sides. So if you realize that if you put 3 here, you have 3 minus 2 into 180 degrees. So you now realize that this is one triangle times 180 degrees, which is equals to 180 degrees. Of course, the sum of angles in a triangle is 180 degrees. We have already shown that. So you can now see that this expression is used to obtain the sum of angles in a polygon. So if you also check out that of a quadrilateral, you also see that a quadrilateral has four sides. Four sides. So if you plug it in here, you will have 4 minus 2 into 180 degrees. So what are you realizing here is 2 times 180 degrees, which is 360 degrees. And you realize that this is exactly a quadrilateral contains two triangles. Okay, so the sum of angles in a quadrilateral is 360 degrees. And if you also go down and look at the sum of angles in a pentagon, which has 5 sides, you still be getting some. So in general, we use this expression n minus 2 into 180 degrees to obtain the sum of angles, interior angles of a regular polygon. So this is, with this breakdown, we are going to go into this, and we are going to be solving a lot of problems right now. So please, you follow us. If you have not subscribed to the channel, it's important you do that, because if you do, you'll be able to access our classes, and if you click on the notification button, it will help you to know when we make new uploads. All these classes we are going to be doing, they are very important. They are going to be very, very good. Try as much as possible to make our explanation to be very, very simple, to the point that every student should be able to understand the concepts we are trying to explain. Please do like what we are doing and subscribe to the channel. As you do that, you will not regret. Thank you.